Hey guys, in this video I'm going to go through an example of finding the general solution of a sine function and then also finding all the solutions within a specific domain. A similar question to this was asked in the 2021 Maths Methods Exam 1 and only 17% of the students got full marks for that question. Not knowing the basic trig angles and not knowing multiple angles were the main common mistakes. And so hopefully after watching this video you should feel confident answering these types of questions. For today's video, we've got find the general solution of 2 sine 2x plus 1 is equal to 0, and hence find all solutions for x is between 0 and 2 pi. To find the general solution of a sine function, we use the rule if sine x is equal to some value a, then x is going to equal 2n pi plus sine inverse of the value a, or x is going to equal 2n plus 1 times pi minus sine inverse of the value a, where n is going to be some integer. Now notice here that x is inside the brackets, and so we're going to say x is equal to this general rule. And if we have anything other than x, then we let whatever's inside the brackets equal the general rule. And so looking at the equation we've got, we need 2 sine 2x plus 1 is equal to 0. To solve for general solutions, the first thing we need to do is make sine 2x the subject. And so rearranging this, we're going to get sine 2x is equal to minus a half. And so inside the brackets, we have 2x. And so applying the formula, we're going to get 2x is equal to 2n pi plus sine inverse of minus a half, or 2x is going to equal 2n plus 1 times pi minus sine inverse of minus a half, where the value of n is an integer. From here what we need to do is work out sine of what angle is going to give us minus a half. Ignoring the minus and drawing our triangles, this is 1, 2 and root 3. This angle here is pi on 6, and so sine of pi on 6 is equal to a half. Since we have a negative, then this means sine inverse of minus a half is going to equal minus pi on 6. And so therefore, the general solution is going to be 2x is equal to 2n pi, and then plus sine inverse of minus a half, which is equal to minus pi on 6, and so this is going to be minus pi on 6. From here we solve for x, and so dividing both sides by 2, x is going to equal n pi minus pi on 12. Or, we've got 2x is equal to 2n plus 1 times pi, and then we've got minus sine inverse of minus a half, and so this is going to be minus pi on 6, and so this is going to be plus pi on 6. And so again, dividing both sides by 2 to solve for x, we're going to get x is equal to 2n plus 1 times pi over 2 plus pi on 12, where n is an integer. And now that we have the general solutions, to find the solutions of x between 0 and 2 pi, what we need to do is sub in values of n into each of these rules. And so if we start by letting n is equal to 0, then subbing this into the first rule, we're going to get x is equal to 0 times pi, which is 0, and then minus pi on 12. And so the first solution is going to be minus pi on 12. But because this is outside the domain, we're not going to include this solution. And so subbing in n is equal to 0 into the second rule, we're going to get x is equal to pi on 2 plus pi on 12. And so simplifying this, if we change this to a 12, this will become 6. And so this is going to become 7 pi on 12. And so the first solution is going to be 7 pi on 12. And then if we let n is equal to 1, then subbing this into the first rule, we're going to get x is equal to n times pi, which is 1 times pi, and so this will be pi minus pi on 12. This is the same as 12 pi on 12 minus pi on 12, and so this is going to equal 11 pi on 12. And so our next solution is 11 pi on 12. Then we sub this n is equal to 1 into the second rule, and so doing this we're going to get n is equal to 2 times 1, which is 2, and then plus 1, which is 3, and so this is going to be 3 pi on 2 plus pi on 12. And so again, simplifying this, if we make this a 12, then we've multiplied by 6, and so if we multiply the top by 6, we're going to get 18. And so this is going to be 18 plus 1, which is 19 pi on 12. And so this is going to be our next solution. And then if we let n is equal to 2, subbing this into the first rule, we're going to get x is equal to 2 times pi minus pi on 12. And so simplifying this, this will be over 12, and this will become 24. And so then we're going to get 24 pi minus pi. This is going to equal 23 pi on 12. And so this is going to be the next solution. And then subbing n is equal to 2 into the second rule, we're going to get 2 times 2, which is 4. 4 plus 1 is 5, and so this is going to be 5 pi on 2 plus pi on 12. And so simplifying this is going to be 12. This is going to become 30. And so this is going to become 31 pi on 12. And this is going to be larger than 2 pi, and so we can't include this into the solution. And so therefore, our solutions are going to be x is equal to 7 pi on 12, 11 pi on 12, 19 pi on 12, and 23 pi on 12. And that's it for this video. I hope you found it helpful, and if you did, give it a thumbs up or comment below and let me know. And now that you know how to answer this question, you should be able to answer the Maths Methods exam question in the 2021 exam. To do this, just log into the Maths Methods Club, and from the main topic, select Functions and Graphs, and then from the subtopic, select Trig or Circular Functions. From the question type, select Tech Free and then click on Filter. This is then going to instantly group all the past Maths Methods exam questions, asking you questions related to trig functions in exam 1. And so if you look at the 2021 exam question 3, this was a question that was similar to the one we just did. And so try out this question and see if you can get 4 marks for it. And after that, try out all these other questions to expose yourself to a variety of ways that you can get asked questions in relation to trig functions. Good luck, and I'll see you guys in the next video.